So, good evening children. So, let us continue this ray optics. In the last class, we have seen about total internal reflection. Of course, we have seen refraction, and following the refraction, we have seen TAR, and we have seen what is the condition for TAR and how does the TAR is taking place. And for TAR to take place, the angle of incidence must be greater than the critical angle. And of course, what is critical angle? It is the angle of incidence in the denser medium, for which the angle of refraction in the rarer medium is equal to 90 degree. So, this is how the TAR is taking place, and this is in the denser medium. And more than this angle, suppose if the ray of light is incident in the denser medium at an angle greater than the critical angle. So, instead of undergoing refraction, it will totally internally reflected in the denser medium. So, we have seen all that, and also we derived an equation mu is equal to 1 by sin c. We have seen some interesting applications, that is phoroprism. As well we have seen the transmission signals through optical fiber. So, through optical fiber, signals are transmitted. What signals are transmitted? Nowadays, we are getting internet signals. So, first it is converted into light signals, and these light signals are passed through the optical fibers. So, the light signals travels very fast. You know very well the speed is 3 into 10 power 8. That's the reason it has been transmitted as light signal. Based on the phenomenon of TAR, with 100%, almost 100% signal security, and reaches the receiver end. Okay, so maybe wondering, we want only electrical signal, how is that possible? There is a term called as transducer. Transducer is a device which converts light to electrical signals or electrical to light signal, that is generally termed as transducer. In order to convert electrical to light signal, LED is used. So, the LED transmit the light signals through the optical fiber, and at the receiver end again it has to convert back to electrical signal, that can be done by means of photodiode. So, that details we will learn in the last chapter. Now, coming to this, here TAR, total internal reflection, how is that possible here? The light is allowed to fall on this optical fiber. It is constructed, or it is made up of silica or quartz glass. So, silica or quartz glass having slightly different refractive index. The inner core is made up of refractive index of higher refractive index mu 2, slightly greater than that of mu 1. The outer cladding is lesser refractive index. Inner one is called core, higher refractive index. The outer covering is there, no? So, that is cladding coaxially constructed, coaxially placed. So, now the light signals from air falls on this core directly, because it has to travel into the denser medium, then only TAR is possible. So, into the denser medium, hits at an angle greater than the critical angle. So, therefore, TAR takes place multiple times, and then signals are sent to the receiver end. And we have seen that the optical fibers are extensively used in transmission of audio and video signals, and of course, it is based on the phenomena of TAR. Each fiber consists of core and cladding. The refractive index of the material of the core is greater than that of the cladding. Where does the light falls first? Only core. When a signal in the form of light is directed at one end of the fiber at a suitable angle, it undergoes repeated total internal reflections along the length of the fiber and finally comes out at the other end. So, now based on TAR, one question I wanted to I wanted to discuss one question. So, we will discuss one question. So, before discussing one question, so let us read out what is that the question says, and then I will redo this again. Okay, right. 3 lights, red, green and blue. So, blue color, green color, red color, refractive index is given. So, red is mu red is 1.39 given. Yeah. Next, mu green is 1.44 and mu blue is given 1.47. Out of the 3, which color ray will emerge out of the face AC? That's a question. So, it is based on the phenomenon of TAR. Allow the light to fall on the prism. It is made up of glass. So, has some refractive index, therefore, it is called as denser medium. This is air medium. We know very well that TAR can happen only if the ray of light travel from denser to rarer. Now, you check the blue light. After falling, blue light, green light, red light falls normally on the face AB. Normally means perpendicular, along the normal. So, go straight, because along the normal angle of incidence is 0, go straight. This also goes straight, strikes the surface at an angle 45 degree by symmetry. Because it is here 45 degrees, so therefore by symmetry it hits at an angle 45 degree. Now, we have to find out whether TAR is taking place or doesn't take place. Whether TAR takes place or not, or refraction takes place. We have to check on that. So, how do we check on that? Now, we know that for TAR to take place, angle I should be greater than angle C. Isn't that? Now, next step. Sine of angle I should be greater than sine of angle C. There are various methods for doing this problem, but this is the very easiest method. What is angle of incidence here, children? Angle of incidence is 45 degrees. So, therefore, I am writing sine 45 degree must be greater than sine C. Sine 45 degree is 1 by root 2 must be greater than 1 by mu. How do you know? Because mu is equal to 1 by sine C. That is what you have learnt in TAR. That is a formula. So, now cross multiply. Mu is greater than root 2 or mu must be greater than 1.414. If anything is greater than 1.414, I mean the refractive index, then you can say TAR takes place. So, which is greater than 1.414? Blue? Yeah? Yes. Green? Yes. What about red? Red is lesser than 1.414, doesn't undergo TAR. So, the red alone, what does it do? It will undergo refraction. What about the rest? This will undergo TAR, this will undergo TAR. It is falling normally, so therefore come straight. So, blue and green undergo TAR and then come straight like that. Whereas red doesn't undergo TAR, undergo refraction. So, hope you understand this is a problem based on TAR. Now, we are going to go for the next topic, that is spherical refracting surface. Spherical refracting surface. How does the refraction taking place? Through the sphere. So, glass sphere. So, let us take a glass sphere. So, I am taking a glass sphere here. So, in this glass sphere, inside it is a glass, this is the center of the sphere, and this is called as convex surface, vex part. So, this is a XPY surface, it is a convex surface. What about the other part? This is the concave surface. Okay? So, how does the refraction is taking place? This is mu 2 because it is a denser medium, and here it is air medium. So, let us take it as mu 1, and P to C distance you call it as radius, okay, the radius of curvature, and this is called as pole of the spherical refracting surface. So, according to the Cbse NCERT syllabus, we have a derivation only based on convex spherical refracting surface, whereas other cases, by knowing this convex SRS, you can apply the sign convention and the rest of the diagrams you can draw it, or equations you can write it. So, convex spherical refracting surface, object lies in rare medium, and image is rare medium and image is real. So, this is the one and only case derivation you have. So, before getting into the derivation, you must know certain assumptions for the same thing. So, let us take the assumptions, and following the assumptions, we will derive the same thing. Okay? So, convex SRS. SRS means spherical refracting surface. An object, a point object is placed in front of a convex spherical refracting surface. A point object O is placed in front of a spherical refracting surface. Derive an expression for the relation. Between object distance, that is u, image distance v, and of course the radius of curvature. That means radius of the spherical refracting surface. So, now I have taken the convex SRS. So, this is called as XP1Y surface. Where is the center of curvature lies? Here at the right hand side. So, the center lies over here. Now, object is a point object. So, I have already told you that there are certain assumptions which you have to write. Assumptions. Point number 1, object is a point object. Aperture is small. And angle made by the object, image, and the normal with the principal axis or small. So, keeping that in mind, we are going to see the certain derivations by applying the sign convention. Just hold on. So, I have taken the assumptions into account. Now, I am going to draw the ray diagram for the same thing. So, first normal always passes through the C. So, this is the normal which is passing through C. Now, the object, ray of light from the object hits the normal at an angle I. Now, after hitting the normal at an angle I, the ray of light travel from rarer medium to the denser medium. Because I have already told you this is a glass sphere. So therefore this is glass. So rarer to denser medium. So how does the ray of light travels? Bend towards the normal. So the ray of light bend towards the normal after hitting the surface. After hitting the surface of the spherical refracting surface xp1y. So now what happens? It hits as well as move towards the normal, and then you get an image. You get an image here. So now this is called as R. Angle made by the object is taken as alpha. I have already told you this is the point object. Now angle made by the image is taken as beta. Angle made by the normal is gamma over here. So now we know that the ray of light is travelling from mu1 to 2. Since it is mu1 to 2, which can be written as mu2 divided by mu1, which is equal to sin I divided by sin R. For small angles, which can be written as angle I by R. Now cross multiplying mu2 into R is equal to mu1 into I. Equation number 1. Put a box. Now we have to take the triangle AOC. Can you identify the triangle AOC here? You identify the triangle AOC. So I have taken this triangle AOC. So can you identify here this triangle? Yes. So this is AOC. Which is the exterior angle in the AOC? In the triangle AOC, exterior angle is I. So I will be equal to, so let me write triangle AOC. In the triangle AOC, angle I is equal to alpha plus gamma. This is equation number 2. Similarly, take the triangle AIC. So let me take the triangle AIC. Yeah. So I am taking the triangle AIC. So this is AIC. After taking this triangle AIC, which is the exterior angle over here, which is the exterior angle? Gamma. So this gamma is the exterior angle. Triangle AIC I have taken. So I should write it as gamma is equal to R plus beta. R, I can write it as angle R is equal to gamma minus beta. Gamma minus beta. Angle R is equal to gamma minus beta. So this is equation number 3. So I have taken this 2 and 3, I am going to substitute in one equation. So 2 and 3 substitute in one. So mu2 into R. Instead of R, you substitute as gamma minus beta. And angle I is alpha plus gamma, so I am substituting this alpha plus gamma. Now all mu2, you bring it, all gamma, bring it together. Mu2 into gamma minus mu1 into gamma is equal to mu1 into alpha plus mu2 into beta. So I have taken this and then I am going to take this as equation number 4. Okay. Now I have to drop a perpendicular over here. Where am I going to drop a perpendicular? From A you drop a perpendicular. Let me call it as N. Why do I need to drop a perpendicular? Because I am going to find out the angles in terms of N. So I am going to take this angle in terms of N. So let me take this and then I call it as P itself. This is N. Now from this triangle ANO, you can notice here, this is the triangle. This is the triangle. Yeah. So ANO, which is tan alpha. What is tan alpha here? AN divided by NO. Similarly, you take the triangle ANI, tan beta you find out. Similarly, you take the triangle ANC, tan gamma you find out. So I wanted to find out tan alpha, tan beta, tan gamma. So here itself let me find out. Okay. So taking this triangle, so here triangle ANO. Take the triangle ANO and find out tan alpha. For small angles alpha, so that is equal to AN by NO. Similarly, take the triangle ANI. So you find out tan beta. For small angles it's beta, so AN by NI. Similarly, triangle A and C you take, tan gamma you find out, for small angles it's gamma AN by NC. So, I found out this is equation number 4, substituting 4 in, equation number 5, substituting 5 in 4. So, let me substitute 5 in 4, fifth equation in 4. So, when I substitute mu 2 minus mu 1 into gamma. So, what is gamma here? AN by NC is equal to mu 1 into alpha. What is alpha here? AN by NO plus mu 2 into beta, that is AN by NI. If you keenly notice that, children, I have already taken that aperture is very small. Can you see here the aperture is very small, I have taken here, aperture is very small. Since aperture is very small, here the point N is going to lie very closer to point P. So, therefore, wherever you write NO, since the point N is closer, you write NO, right? N to O distance is approximately equal to P to O, because the aperture is very small. So, the point N is lies closer to P. So, wherever you write NO, write it as PO. So, we will write here, yeah. So, therefore, mu 2 minus mu 1, AN get cancelled by PC. So, aperture is very small, so replace N by NC is equal to PC, NO is equal to PO, NI is equal to PI. So, therefore, mu 2 minus mu 1 by PC is equal to mu 1 by PO plus mu 2 by Pi. Now, substitute sign convention you apply. So, how are we going to apply the sign convention? We will check on that. So, here we will apply sign convention. Light always comes from the object. So, now what is PO? Object distance. PC, radius of curvature. Pi is V. So, therefore, I have to write PO is equal to minus U. PC is equal to plus R, because it is coming along the direction of the light, P to C. And then Pi is also equal to plus V, substituting that sign convention. So, this is the main equation where you will be using it for doing the numericals always. So, therefore, I can substitute the sign convention. Substitute sign convention, mu 2 minus mu 1 divided by R is equal to mu 1 divided by minus U plus mu 2 divided by plus V. Now, divide by mu 1 throughout. So, divide by mu 1 throughout, because mu 2 by mu 1 is equal to mu. Since mu 2 by mu 1 is equal to mu, so therefore, I am writing mu minus 1 by R is equal to minus 1 by U plus mu by V. So, this is the final equation for convex SRS. But though this is the final equation, always we have to use this formula for doing numericals based on spherical refracting surface. Okay, so keeping that in mind, we are going to go for the next derivation. So, that is before going to go for the next derivation, here one problem based on that we will check. A spherical surface of radius of curvature R, a spherical surface of radius of curvature R separates air from glass of refractive index 1.5. The center of curvature is in the glass. A point object P placed in air is found to have real image Q in the glass. So, you get a real image Q in the glass. So, let us suppose here is the center and here is a Q image. The line PQ cuts the surface at a point O. This is P. Okay, and PO is equal to OQ. So, O is the object, let us suppose, and this is the normal. So, here it is given PO is equal to OQ. a line PQ cuts the surface at point O. So this is line PQ cuts the surface at point O. So this is O. So here it is P. So here it is given PO is equal to OQ. So I mean it is given that it says that PO is equal to OQ means object distance is equal to image distance given U is equal to V. You have to find out what is distance PO. PO is equal to what? So this is an object. At point P, object is placed. So the ray of light from the object hits the normal and then it says that Q image is obtained. So image is obtained at Q. So you are asked to find out the object distance. That's all the question. We have already done the derivation for convex SRS. Take this formula, that's it. Apply sign convention, you will get an answer. Can we take this formula? Yes. Mu2 minus mu1 divided by R is equal to, what is given? Mu1 by PO plus mu2 by PI. So same thing I am going to write here. So mu1 by PO is minus U plus mu2 by V. Given mu2 is equal to mu glass, which is equal to 1.5. Mu1 is equal to mu air, so that is equal to 1. U we do not know, so let us take U is equal to minus x. How do you say U is minus x? Because you have to measure the distance only from the pole of the spherical refracting surface. How we have seen there in the mirror, same thing, measure the distance only from, measure the distance only from the pole of spherical refracting surface. So here, from here you have to measure. I have mentioned pole as O here because as per the question. So now the light comes from the object, but you have to measure the distance against the direction of the light for an object distance. Therefore U is negative and V is equal to plus x. So therefore substituting you get an answer. So 1.5 minus 1 divided by R is positive. What is R over here? R is radius of curvature, R only. So that is equal to mu1 divided by minus x. U is the negative. So mu1 divided by plus x. What is mu1 here? Mu1 is 1. So therefore I take it as 1 plus mu2 is 1.5 divided by x. So 1.5 minus 1. So that is equal to 0.5. So 0.5 divided by R. So that is equal to 2.5 divided by x. So therefore x equal to 2.5, 1.5. So that is equal to 5 times. So therefore I can write this as x is equal to, x is equal to 5R. X is equal to 5R. So I can write it as x is equal to 5R. So this is how you need to do this question. So based on that, there is one more question. Light from a point source in air. Falls on a convex spherical refracting surface. So this is convex spherical refracting surface of refractive index 1.5 and radius is given as 20 centimeter. So this is point source. Calculate the position of the image when the light source is at 1 meter from the glass surface. So 1 meter, so that is equal to 100 centimeter. So object distance is known. So given U is equal to minus, you have to measure the distance only from pole. We have seen no earlier question. Same way, where is the object here? Light comes from the object, but you have to measure from P. So therefore U is equal to minus 100 centimeter. Okay, right. What is R? R is positive or negative, children? R is positive because along the direction of the light. Where are we supposed to measure the light from? P. Why U is negative? See, you are measuring U from pole in the opposite direction of the light. So U is negative. What about R? You start measuring the distance only from P. So P to C is along the direction of the light you are measuring, therefore R is positive, plus 20 centimeter. We have to find out. So what is the formula? Recall the formula, mu2 minus mu1 divided by R is equal to minus mu1 by u plus mu2 by v. So that is equal to, what is mu2 here? Mu2 is 1.5. So 1.5 minus 1 by 20 centimeter is equal to minus 1 by u is minus 100 plus 1.5 divided by v. So shall we calculate? Yeah? Yeah. So therefore 0.5 by 20, 1.5 is 0.5 by 20. So 0.5 is 1 by 2. So 1 by 2 into 20, 1 by 40 is equal to 1 by 100 plus 3 by 2v. Now 1 by 40 minus 1 by 100 is equal to 3 by 2v. You want to cancel out with the 2? Yeah, you can do it. R 1 by 20 R cancel out with the 2. 1 by 20 minus 1 by 50 is equal to 3 by v. Yeah. So now take LCM 100. So 5 minus 2 is equal to 3 by v. So 3 by 100 is equal to 3 by v. So 3 get cancelled. So v will be equal to what? 100 centimeter. Check on that whether it is right or what. Check on that. So 1.5 minus 1, that is 0.5. 0.5 is 1 by 2, so 1 by 40. That's equal to 1 by 100 plus 3 by 2v. 1 by 40 minus 1 by 100, that is equal to 3 by 2v. Or dividing, that means you have to strike out with the 2 or take out 2. When you take out 2, then you will be getting 1 by 20, 1 by 50, because I am taking out 2. So 2 in the left hand side and right hand side get cancelled. So 1 by 20 minus 1 by 50 is equal to 3 by v. Take LCM, then you get the answer. So 5 minus 2 by 100, that is equal to 3 by v. So hope you understand. Anyhow, check that. Check whether the calculations are correct. You have to check. Okay, v is equal to 100 centimeter. So now using this convex SRS, we are going to see the lens maker's formula. Lens maker's formula. The lens maker's formula consists of two surfaces. One is convex SRS, another one is concave side. Combining together you get a lens. So let me call this as C. This is called principal axis. This is called as XP1Y surface. This is called as XP2Y surface. You must be knowing that for XP1Y surface, where is the radius of curvature? In the right hand side. So let me call it a C1 here. And you also must be knowing that for XP2Y surface, where is the radius of curvature? Here. So C2 here. Okay. Now C to C1 is positive, that is R1. Whereas C to C2 is negative, that is R2. So I have to write CC1 is equal to plus R1 and CC2 is equal to minus R2. So now itself I am writing. Before getting into this lens maker's formula, I have to write an assumption. What is an assumption? That is lens is thin. Lens is thin. And the remaining all you can write it, object is a point object. Object is a point object. Aperture is small, all that you can write. But which is a major assumption which you have to write is lens is thin. Which is a major sign convention which you have to write. CC1 is plus R1, CC2 is minus R2. Object is over here. I am taking an object here. The rays of light from the object hits the normal and then you will get an image. So let me go to the next page. So now this is lens. Now this is C. I have already mentioned XP1Y, the same thing I am mentioning it. The rays of light from the object now hits. After that what happened? Due to this XP1Y surface, you get an image here. This image is acting as a virtual object. Virtual object for xp to y surface. For xp to y surface, this is acting as an object, virtual object. Since it is acting as a virtual object, therefore, you get a final image here. This virtual object. So, you get a final image here. So, this final image is a real image. So, this distance you call it as V, this distance you call it as U over here. So, therefore, for xp1y surface, we have already learned that for xp1y surface, we already learned that the ray of light is travelling from mu1 to 2 and you get an image here, that is I1. So, therefore, I am writing as mu minus 1 by r is equal to, where have we done? Here we have done mu minus 1 by r is equal to minus 1 by u plus mu by v. Same thing I am writing here, same thing I am going to write, mu minus 1 by r, r is nothing but r1 is equal to minus 1 by u plus mu by v. You got it? V is nothing but V1, I am taking this as V1, mu by V1, that is equation number 1. Whereas for xp to y surface, this is xp1 y surface, I am going to take xp to y surface. You take xp to y surface. For xp to y surface, how is that diagram going to be? This is the diagram, and which is the C2 is the center curvature. So, therefore, this is R2. R2 is negative here because you are measuring it against the direction, but this is acting as an object. So, this is acting as an object. V1 is an object, and then we get an image here. So, for xp to y surface, I have to write mu minus 1 by minus R2 is equal to plus 1 by V minus mu by V1. So, therefore, plus 1 by V minus mu by V1, this is equation number 2. That is all. Add both, adding both, adding 1 and 2. When I add 1 and 2, you get mu minus 1 into 1 by R1 minus 1 by R2 is equal to minus 1 by U plus 1 by V. The remaining stuff that get cancelled. Children, we know that even the object is at infinity, if U is equal to infinity, image is at F. So, therefore, mu minus 1 into 1 by R1 minus 1 by R2 is equal to 1 by F. So, this is the final formula for lens makers. So, I can write final formula for lens makers formula, which we derived, mu minus 1 by R is equal to, this is final formula, 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. R, I can simply write it as 1 by F in air is equal to mu glass divided by mu air, or you can simply write it as mu 2 divided by mu 1 minus 1 into 1 by R1 minus 1 by R2. So, this is the final lens makers formula. So, based on that, you have a number of questions, and before going to the questions, I am going to give you sign convention for certain spherical lenses, sign conventions. You must definitely incorporate the sign convention while you are doing the problem. So, I am going to take convex lens. When you take a convex lens, always take, this is P1, this is Y, this is P2. So, now convex lens, R1 is positive, R1 is positive and R2 is negative. Which is R1 positive? This is only R1. Which is R2 negative? This is only R2. So, therefore, R1 is positive, R2 is negative. Convex lens. Next is equiconvex lens. When you take equiconvex lens, radius is same. R1 is equal to R2 is equal to R. So, therefore, I can write it as R1 is equal to plus R and R2 is equal to minus R. Got it? For equiconvex lens, equivalent radius, equiconvex lens, equivalent radius. You got it? R1, R2. So now, plano-convex lens, plano-convex lens. You take one surface is plane, other surface is curved. So this is P1. So for a plano-convex lens, R1 is equal to infinity and R2 is equal to minus R. Plano-convex lens. Concave lens. You take concave lens. So you tell me, any guesses? Yeah, you can do it. So this is P1. So therefore, R1 is negative and this is P2. So therefore, R2 is positive. So R1 is minus R1 and R2 is plus R2. So keep that in mind and then you have to do the problems. Only one problem I am going to teach you here. A convex lens, an equiconvex lens or a convex lens, you can take convex lens made of glass of refractive index 1.5 having radius of curvature, R1 is equal to having radius of curvature 10 centimeter and 15 centimeter respectively. Find its focal length. That is the first question. And to the second question, if the above lens is immersed in water, if above lens is immersed in water of refractive index mu is equal to 1.3 or you can call it as 4 by 3, how does the focal length changes? How does the focal length changes? So now let us see this question first and then we will go to the rest. So first of all, here convex lens. You take convex lens. Now you tell me whether R1 is positive or negative. So now R1 is positive. Since R1 is positive, I am taking R1 is equal to plus 10 centimeter and R2 is how much? 15 given, right? What's the sign convention? Negative. Minus 15 centimeter. How do you know? Now only we discussed. Same thing you apply. Whenever you do numericals, keep it in mind that you have to apply the sign convention to get the answer. So now 1 by f is equal to, use lens maker's formula. First write formula. For formula it carries half a mark. Mu glass, that is mu 2 by mu 1 minus 1 into 1 by R1 minus 1 by R2. You have to know mu air is equal to 1 throughout. Or you can write 1 by f is equal to mu 2 is 1.5 by 1 minus 1 into 1 by 10 plus 1 by 15. Now that is all. Use the calculation. 1 by f is equal to 0.5, that is 1 by 2 into 30 is the LCM, 3 plus 2. So that is equal to 5 by 30. 1 by f is equal to 1 by 2 into 1 by 6. Therefore, f is equal to 12 centimeter. So focal length in air which we found out as 12 centimeter. Quickly go to the next one. What if the above lens is immersed in water? It is fully water. I am going to immerse this lens. So the ray of light not goes from air to glass, instead goes from water to glass. So therefore, my answer 1 by f in water is equal to mu glass divided by mu water minus 1 into 1 by R1 minus 1 by R2. That is all. I modify the formula, the equation. Same formula, but only thing mu glass by mu air I have to write, but instead I am writing mu glass by mu water. Very easy, children. You can substitute now, I get the answer. What happens? So that is equal to 1.5 I am taking as 1.5 as 3 by 2, just for by convenience. 3 by 2 divided by 4 by 3 minus 1 into 1 by 10 plus 1 by 15. Of course, this is 1 by 10 plus 1 by 15 is 1 by 6. So, same thing I am going to apply. So, that is equal to 9 by 8 minus 1. So, that is equal to 1 by 8 into 1 by 6. So, 1 by 8 into 1 by 6. This is 9 by 8. 9 minus 1, 9 by 8 minus 1, that is equal to 1 by 8. So, therefore, 1 by F water is equal to 8 6 are 48. So, therefore, F water is equal to 48 centimeter. So, what is happening to the focal length? Increases. Still it is converging. How do you know converging? Because you are getting positive sign. So, hope you understand the convex SRS concept. Hope you understand TAR concept. Hope you understand lens maker's formula and the problem related to the lens maker's formula. So, again we will meet with some other concept. Thank you children. Till then, you will have to study, take notes, alright, take notes and then send me as PDF. Thank you children.